manage it. Okay? So I have written the problem up here. It's worded a little bit differently on the paper, but I think this makes sense to you, right? That I just wrote this right here. Does that make sense to you? Okay. So I know ultimately, as with all inequalities, there's going to be a number line involved. And I need to put some things on the number line. So we need to jump in and start thinking about how we're going to do that. So what do you think?
-4 is the number line.
So -4, Kellen says, I don't know what else is going on in this problem, but whatever is going on, x has to be bigger than -4. Would everyone agree with that? And then he says, I need to really have the same consideration for this. Now, in a perfect world, that would be factorable. Because then I could factor it and get 2 more dots on my number line. Unfortunately, it's not factorable. So what are we gonna do? We're still looking for those 2 dots, right? So we'll use the quadratic formula. Negative b plus or minus the square. Now, do you remember what happened yesterday? We had one kind of like this yesterday. What very wonderful thing happened yesterday? This came out to be imaginary. So we knew we couldn't put dots on the number line when, when they're imaginary. So we figured out that this whole thing was always positive. Not this one, but the equivalent yesterday. And that meant we didn't have to put any dots on the number line because every number worked. Well, here we are going to have dots on the number line.
What did the original problem have like differently to make it a hedge?
When we solved this, the discriminant came out negative. It was just quadratic. By the way, it's all video. Okay, so -1 plus or minus the square root of 21 over 2. Everybody okay with that? All right, let's get our calculators out. We get some decimals for this. We could, if we didn't have a calculator, we could approximate. How would you approximate the square root of 21 if you didn't have a calculator? About 4.5, somewhere between 4 and 5, so about 4.5. But since we got a calculator, let's go ahead and tell me. What? 4.58. So one of our answers is 4.58. And the other one is
No, I thought you were asking for like the actual square root of 21.
Oh, okay. Go ahead and put it in then. Yeah, so -1 plus your square root of 21 equals divided by 2.
1.791 and negative
1.791 negative.
-2.791.
All right. Does everybody agree with Fred now? Did these look okay? Everybody okay with that? All right. So let's see what happens here. -2.791 and 1.7. Okay. I think there's more dots that go on that line. I would call these my domain dots, because these came from dealing with the actual pieces of the problem. Now I have to put it all together though. So how am I gonna find my solution dots? Well, what would you do if this were an equals? You drop the logs and just solve x squared plus x minus 5 equals x plus 4? Is that what we do? So x squared equals 9. So when I set these equal to each other, and I know in the original problem that's supposed to be a less than, but to find where those dots go, I pretend it's an equation and I solve it. So now I have a dot at -3 and at +3. We talked about this yesterday. Yesterday's problem only had 3 dots because of what happened over here, but we talked about the fact that if there were solutions to this, we could have more dots, and we do, we got 5. Okay? All right, we got all our dots. We have dots from the domain, and we have dots from solving the equation. Okay, now what do? We start plugging in, and you're gonna have 1, 2, 3, 4, 5 to plug in. So go ahead, use your calculator to help you, and you want this side to be less than this side. Start plugging them in, and see what happens.
Wait, on this board,
Yeah,
All you gotta do is
so it can't
Plug
go
in values.
anywhere to negative infinity then?
no, because
equation.
this wouldn't make any sense.
And then you shade it.
Okay.
Remember?
So it just cuts off past.
It cuts off at that point. Now, you can go ahead and try numbers over here, but they're not going to work
Okay.
because it can't be in that side right there.
What if the sign was flipped though? Could you have it still?
No, no, regardless. Yes, so let's make sure we're clear on this, guys. I lopped off this end of my number line. That has nothing to do with that symbol. That symbol could be anything, including an equals, and I still couldn't have answers over here because this guy has to be bigger than 0, no matter what. You understand what I'm saying? So that sign has nothing to do with getting rid of this side of the number line. Nothing, because it's less than or greater than less than. All right, so we're plugging in numbers now. I'm trying to figure out.
.791, I think it worked.
Call it that.
I plugged it in,
We need it works.
like, h of x is greater than,
Okay, but you remember, that's rounded off.
That's
That's going to be a zero.
it will.
Yeah, if you put in the real number, like if you put in whichever one, this one, like you put in the whole thing, it's not gonna work, yeah. Yeah.
Is that the same for all the dots? No, the dots will run over.
Now, if these two dots, they could work.
Versus when you're
If there's an another two on that. So, because these are the solution dots. These are the domain dots. And domain is always going to be bigger than zero. There's no way to ever equal that. Okay, so these dots, they come from the individual parentheses, will always be open. These could be closed if you have the right sign.
So we can still plug negative equals three?
Yeah.
Okay.
No. We're plugging, guys, when we're plugging in numbers between these dots, right? We're trying to figure out where we're shading. We're not plugging in the dots. We already know the dots are open. We're plugging in numbers in between the dots.
I was asking, should we plug in the 3 and negative 3 to see if they can be closed?
They can't be closed because if you put in 3 and negative 3, they're going to be equal to each other. And I need the one to be less than the other one. Okay, because when I got the 3 and the negative 3, I got it by setting them equal, so I know it's going to start with. Okay. So no, you don't need to check any of those numbers. You need to just check those spaces.
Sure.
Okay. All right, so we're Pat, Art, are you guys, finished already?
We're finished, but we don't know if we're ready.
Okay, well, we're gonna find out in a second. We're gonna compare.
I think Enzo should go down the board.
This board,
Actually, let's let Enzo teach us the rest of this lesson.
this board.
Let me finish, I'm not quite done yet.
That's what I got, but I don't know.
I'll shave for you for sure.
Lunches every day. I've been like 16 years on this earth. Everybody has lunches every single day. You can't have lunch tomorrow between.
Ben, you got it figured out?
I think
Okay,
it works.
just say yes or no. Do I shade here?
No.
No. Shade here?
Yes.
Shade here?
Yes.
Shade here?
Yes.
Shade here. I wanna look at this section right here. What did you plug in?
Zero.
0. Now, be careful, because when you plug in 0, what does this say? If I plug in 0, it says ln what? Whoa! Can you do ln negative 5? No. So this section shouldn't be shaded. That section should not be shaded because if you plug in, now he picked 0, but it would be true of any number in that interval. If you plug it in, this is going to turn out negative. Can
You can't do that.
ln a negative number? No. No. I agree with the rest of it. So I think your answer is negative 3 to negative 2.791, and then 1.791 to 3. That problem has a lot going on.
You might have said this earlier, but, what was the reason for, like, the -4 not continuing?
What happens if you put negative 5 in right here?
Negative log.
Can I log a negative number? Yeah.
On these type of problems, are the circles always gonna be open? Will they ever be closed?
The ones that come from the domain, and when I talk about that, I'm talking about the ones that come from the individual parentheses. Those will never be closed. Those will always be open. Because whatever this is, it has to be bigger than 0, not equal to 0, bigger than 0. So these are always going to be open. Now, when you solve, those could be closed depending on the symbol in the problem. If this had been an or equal to, then those dots would be closed in. Okay? Any other questions? Well, guess what you're gonna do right now? Oh, wait. Well, this one's a little different because it's an exponent, but go ahead and see what you can do with this one. Go ahead and try example 6. Example 6. I think this one's gonna be a little bit easier. No, you're not overcomplicating it. It's not bad at all. Wait, find the inverse. We don't want an inverse. We just want our function to be less than or equal to negative 31.
We're gonna look into it.
Is there a logarithm in it?
No, but it's an extra.
Well, we're gonna solve for x. And I don't think we're gonna do that. Because if we subtract 1,
Would you do the log thing, or would you do like 1 minus 4 to make it 3?
and divide by negative 4,
You gotta divide it. Which means you gotta get this exponent down. How do you get rid of this in the front? Just divide by 3.
Guys, on a scale of 1 to 10, example 5 was like a 9, okay? But example 6 is like a 2. Don't make it hard. Don't make it hard. You want your function to be bigger than negative, or to be less than negative 31. So subtract 1, divide by negative 4. Now, since this is an inequality, when I divide by negative 4, I'm going to have to flip my sign. And then I've got a 2 over here and an 8 over here. Well, that's nice, because 8 is 2 cubed. And now that I have the same base, I can lose them. And it looks like x has to be greater than or equal to 6. Because I divided by a negative.
Did you add the 3?
The sign flipped right here. Because I divided by negative 4.
So since there's no log, we don't need
No,
like
I did not.
No, we talked about that yesterday. By nature of what they are, there's an exponential, here's a logarithm. Do exponentials have domain issues? No, because it's negative infinity to infinity. Do logarithms have domain issues? Yes, because they're cut off right here, right? So exponent problems are easy peasy compared to logarithmic problems. Okay? All right, well that finishes 2.13, so that homework will be due on Thursday. But I do want to look at the next page. We're going to spend the rest of today reviewing and our next class reviewing, and then we'll be having a little quiz, a mini quiz, to kind of get us all back on track. But let's start with this next page, which says looking for the question mark. And some of these are super simple. This is just a kind of a review of solving lots of different kinds of equations. So go ahead, let's get started, let's spend about, a few minutes, see how many of these you can get solved. And then we'll talk about them, get them on the board,
Write out one step.
and continue reviewing. This says write out each step. You don't have, I mean, some of these are so easy. Don't worry about writing out each step. Write out as much as you need to.
D for 25.
D for number?
I just did like 4. There were so many things for me. How did you in one pot? There's a big pot. Campfire. Do that.
Have we gotten 1 and 2 done? I'm out of room up here. I want to raise something. Are we good with 1 and 2? I got these answers. I don't know. Does that look okay to everybody?
How did you do D?
Okay, D is, I needed logarithms because there's no common base between 4 and 27. So I took the logarithm of both sides. I did not type that into my calculator, but that will be some decimal.
How'd you set up the X log for?
Wait, did I do 3? Oh, I skipped 3. Okay, well, I need to do 3. Well, I thought I did 3. Where did I write those answers? Oh, because 2 and 3 are the same questions. Yeah, okay, so that's why 4 didn't make sense to me, because I skipped 3. Okay. All right, so any questions about 1 and 2? And the answers to 3 are the same as 2 because it's the same set of problems. And I'll be honest, I would not change A, and number 3, I would not change A in the logarithmic form. I would just leave it like it is and think about 81 as being 3 to the 4th. B, I could change into exponent form, 17 to the 0. And the same with C. And then D, I have to use logarithms to solve it because there's no common base between 4 and 27. I took the logarithm of both sides. So when I take the logarithm of both sides, the exponent comes out in front. And then I just divide this off. All right, we okay with 1, 2, and 3, and 4? All right, and then I started these. I'm gonna go ahead and finish them. Let's keep working. Get these. Cole, are you done with these?
Yes.
Maybe check them with mine. I don't see answers to all this. Come on.
Well, you know, everything with 0 power is 1, right? So 1 equals. You just square both sides.
So what did you just do?
C to 0 to the ln is log. E to 0.
My sisters anymore? My sister.
Square both sides, get rid of that.
When is spring?
Just get exponents A equals 1.
Oh, 3
That
to the
base
right.
both sides.
Tomorrow.
Yeah, 0 to the
I got 1,19,680.
Big talks again.
Wait, that's
Yeah.
not what
It's actually crazy, bro. We went from January 1st to January 14th.
At the beginning,
Three
right?
days.
Good, yeah.
You're not
Like January 14th.
So in 5A, as you're solving 5A, make sure that you are moving that 4 to the other side before you start messing with the equation. Get that logarithm by itself.
So if we divide 4 into
You done? You match? Me? Yeah. All Alright, Avery matches me, so I think I'm good up there.
I think that
Alex matches too, good. So when you are done with the front of this page and you have checked all of your answers and they match, or you've asked about them, go ahead and do the back side to check your understanding. Let's finish the front side first. We got plenty of time. We want to get everything solidified here. When you get to the very last problem, if you do it the way I did, you get a quadratic and you have two answers. But remember, in this problem, number 7, can x be -2? No. So that's why that answer wasn't included. That would be extraneous. All right, Jess, you done? Everything's not okay?
Oh, because it'd be for
No, it's only supposed to snow for about 20 minutes.
Let it snow, let it snow, let it snow.
It's supposed to be spring.
Just stay focused. You're in school, so you're safe.
It wasn't just when I was in Europe, it was like,
Can you take a water and a negative number?
that was horrible. I saw
Right?
it was gonna be really cold. And then the 40s.
Can you stop talking crap?
If we just add it though, we're gonna cancel out.
Why you assuming?
I'm not assuming anything.
Wait, can you just-
Okay, how about number 5? Is everybody to number 5? Number 5, check your answers, here they are, A, B, and C. Everybody good with that? Everything there okay? Number 5? Okay, 6, here's A, I got 11. And then B, C, and D are over here.
Can't be negative.
Has everybody gotten to number 6? You did your check.
Cause like, it's saying that this number minus this number is equal to the same number. That means that logically, this is just twice as that way. But,
Well, why don't you just solve this equation? I don't know, so.
I don't know.
Get a 7 equals 0, is that correct?
Yeah, that
Cool,
one.
it's a quadratic equation. You can do that. Move everything over to the side.
Now the other
Of course,
one.
this is quadratic formula. You done with the front? Get started on the back. Alright, so we're gonna have some volunteers come up and work through teaching, kind of like teaching, the back side, to check your understanding side. So when you are all good on the front, I'm gonna come around one more time. I want you to stop me if there's something on the front side that you're not sure about.
I'm gonna check
Took my binder out.
Okay, we get it put back together, you can always get it from campus also. But the answer is.
And didn't you say like if you were to like put it on this, really just-
That's right there. guys good on question marks? Yeah, that's what it is. Scout. They're all good on all these question
So I didn't want to do
marks.
that one, no. Oh, wow, yeah,
Back row, you guys good on question mark? Bennett? Gabby, you good here? Boys, we're all set on the question mark side? Good? All right, so we're working on the check your understanding, and we're gonna have some help. From our awesome volunteers.
Oh, I was comparing this to that particular section. I'm looking up here.
Oh, the G has an X.
This is X, and the X comes up front. I just did that because the.
All right, I want everybody
this one
paying
has Ellen
attention.
and
Declan is gonna walk us
That's
through
not
one of these
I
problems.
tried to do that one, but I couldn't get it.
Which one are you doing?
All
All right, he's doing 1C. So if you struggle at all with 1C, listen to him because he's gonna talk to you while he's doing it.
First.
Loudly. And let's use this black marker because that one's not showing up very well. I love it, it's one of my favorites, but it's wearing out. So he subtracted 5. They good with that?
I took the ln on both sides.
Natural logarithm both sides.
Do it.
And what happens on the left side, Declan?
The e cancels out. It's
Yep.
just x plus 1.
And then all he has to do is subtract 1. And his answer is ln 15 minus 1, which we can either read that way or get a decimal, if that's what we're supposed to do. But we just had to know our calculator. Everybody good with that? Love it, Declan. Good work. Good work. I don't think we actually need 1A. Anybody to come up? What do you do with 1A? Luke knew it. And it says 49 to the 1/2, which means what? Square root of 49. So the answer there is 7. Perfect. Anybody want to do 1B for us? It's not a hard problem. You can do it. I got it. Fred's got it. All right. Fred's going to talk us through 1B.
So first you just subtract 10 over, so you get 6. X equals 36. And then you can either make that 6 squared and cancel out the 6's, or what I just did is that I know that 6 squared equals 36.
perfect,
So x
beautiful.
equals 2.
Good job, good job, Fred. Everybody okay with that one? That seems easy enough. Okay, I'm not sure we need anybody to come up and do number 2A. I hope when you looked at 2A that you said 2x minus 2 equals 11. And then 2x equals 13. So 13 halves. Now, of course, in the back of your mind, you're thinking that has to be positive. So if I've gotten negative 13 halves, I'd say no solution, but that works, so that's my answer. Okay, what about 2b? 2b is a little bit bigger problem. Anybody want to come up and walk us through that? All right, Cole?
Do I like talking stuff?
Yeah. Tell me what you're doing.
You gotta start by like getting the x by itself. So you gotta like get the 6 away. You do that by like 2 to the x to the squared, and then 2 to the negative 6 equals to the 8. And then you can simplify that to 1 over 64. And then to the x squared. And you can bring that over and get 512. Then you can just log that. And then it like comes out. You want to take over?
Okay, this is
I'm
one of
passing the torch.
this is one of the beautiful things
I'm passing it.
about mathematics. There's always more than one strategy. Wait, before you do anything, I want to talk about is this wrong? No. No. Now, again, mathematicians are inherently lazy, and so we try to do things in as few steps as possible, but this is not wrong. What about this step? Is that wrong? No. What about this step? Is that wrong? No. Now, after that, things start getting a little wonky. But there is nothing wrong with your thought process, Cole, in doing that. All right? Now, I think Enzo is going to take a little bit different attack. No problem.
I just made the bit or this 2, so like 2 to the 3rd equals 2.
Is that one running out too?
I think so.
Nice work, I can almost see it.
Nice.
So you the x squared minus 6, and then x squared minus 6 equals 3. I just dropped the pieces.
That's wrong.
Plus or minus.
Plus or minus. So wrong.
Plus or minus.
50%.
Now,
Minus 1.
since this is an exponent problem, is it okay to put that negative 3 in there as part of the answer? 100%. 100% fine to do that. So the answer is plus or minus 3. All right, are we okay with that? And keep in mind, there is never, it's always okay to have your own strategies to doing a problem. That is fine. When you started logging things, that's where things kind of went crazy. But up to that point, you were dead on. It was okay to do that. All right, we good so far? All right, we got a couple more to go. Anybody feel like, all right, now number 3, anybody feel like you can solve it? All right, Kellen's got number 3. And, anybody have an answer to number 4? Has anybody done number 4 yet and has an answer? Alex, what'd you get?
I got 0.427.
0.427?
Or negative, sorry, negative 4.
Negative 0.427? And then number 5, can anybody come up and find the inverse? This is, we practiced this a little bit yesterday. Anybody feel confident on number 5? Kelly, come on up, you're doing that one. You're doing that one. And then, who can find the inverse? Well, you've already come up, Declan, thank you for, well, let's get someone else here. Who else can come up? Okay, you're finding the inverse.
How am I gonna get school?
It's Big Al. You know why they call him Big Al? That was his big brain.
Did anybody have any trouble doing the calculator problem? Is everybody able to get negative .427? The calculator problem? You done it?
I used to see money that.
I have not done problem number 3. Kellen says, would you get 1/4?
I did.
Kellen got 1/4. Anybody match that? Olivia? You did it with everything else, so you don't count. Avery, you got it too? All right, I'm getting a lot of 1/4s. Number 3. I haven't done it yet. Yeah, I got 1/4 also. So, anybody have a question about that problem number 3?
So,
All right, let's listen to Alex. He's gonna walk us through his inverse.
for what I did is I flipped the x and the y in this step, and then I moved the -5 over to this side, and then I took log 3 so that this would cancel out and make the problem easier. And then this was just like the simplified version of that. And then I moved the 1 over, and then divided by 4.
All right, any questions about that? They do expect me to teach you people something, so someone ask a question. Anybody have a question? Yep. Yep. How do we do the calculator one? Well, we always have options, right, when we do calculator problems? So, one option would be to graph this as y1 and this is y2 and then see where they cross. Alright, that's one option. So I'm going to go ahead and do that. Fine option. So y equals 6. Remember, to get e, we second ln. That's how we get an e. And then 25. Now, for my window, remember one of my equations is 25, so my window's gonna have to go up to at least 25. Remember, okay, y min and max cannot be the same. So, and it's y equals 25. So I would go with That's supposed to be -1 point, I don't know, let me check. No, he's right, it's -0.427. Double check your equations, make sure you put in your
He had an asterisk. He had like one of those asterisks on his
Okay. Alright, so let's quickly, we got a couple more minutes. The next page was is another review page. I think we've done this before. These big 10 things, there are 10 digits and 10 problems. And every problem will be one of the digits. So the answer to one question is gonna be 3. And the answer to another question is gonna be 7. And each of the digits is used only once, okay? So we didn't get through as much today as I hoped. So what I'd like you to do is, you got homework, don't you? So never mind. We'll start here tomorrow and finish this. I want you to work on your homework though. Start getting going on that. 2.13. Which you already have.
213 do.
All right, read the all. Let us pause at the 9th.